Okay, we're live. Hey, hi everyone, and welcome this afternoon. I am Derek Weeks. I'm a vice president at Sonatype. I'm also co-founder of the All Day DevOps Conference. I'm joined today by Dr. Stephen Magill. He is CEO of MuseDev and principal scientist at Galois. And we are going to talk to you about some research that we've been collaborating on with some others over the last 10 months or so, or year or so by now. So an organization's journey to excellence begins once it ceases to sacrifice quality for speed. Now, wait, we're at a DevOps conference, right? We talk about speed all the time. And we know that high velocity, exemplary DevOps practices deploy 67 times more frequently, according to DORA and the state of the state of DevOps report from DORA. We know they have 7 times lower change failure rates. We know that they're 2,600 times faster to recover when failures happen within their organizations. And we also know from the state of DevOps report that these organizations are 1.7 times more likely to extensively use open source within their environments. So over the past 5 years or so, almost 6 years now, I've been studying the use of open source components within software development around the world across tens of thousands of organizations. One of the things that we saw last year, and we've documented this in a report we're going to share with you, is that in the Java development realm alone, about 10 million Java developers last year consumed 146 billion download requests of Java open source components. If you're a JavaScript developer, you have JavaScript developers in-house, 6.5 million JavaScript developers around the world consume an average of 60,000 components a year, and they are downloading as a gross population over 11 billion NPM packages a week. The consumption of open source is prevalent in DevOps practices as well as non-DevOps practices. What this means is when we look at the average enterprise like your own, we studied over 12,000 enterprises using open source within their development practices. Just in Java alone, the average organization is downloading 313,000 Java open source components on an annual basis. They are downloading these from over 2,700 different suppliers or open source projects within the community. These are projects or suppliers that they are relying upon to write code for them and to source that as the suppliers externally, because I don't want to write the code myself. And we're relying on over 8,200 different versions of those projects or individual releases from those projects within those downloads. But we know not all of those downloads are created equal. In fact, almost 1 in 11 of those downloads had a known security vulnerability at the time that it was downloaded into your enterprises. Now, what does this really mean from we're consuming all of this open source? Well, it means that 85% of the applications that we are building are composed using code from these external suppliers, code that we didn't write ourselves, that is making us more efficient, that is allowing us to be much faster in our development practices as a result. And it was part of this knowledge of this massive consumption that's happening and the speed of development and efficiency that's happening that paired Stephen, myself, Gene Kim, Bruce Mayhew, Ghazi Mohammed, and a number of other security researchers and data scientists to pull together the state of the 2019 State of the Software Supply Chain report. So we spent almost a year collaborating on this research, and we're going to share a lot of that research with you today. To give you a sense of kind of what research it was, we walked through a software supply chain, which every one of you has within your organization or relies upon, where you have open source projects open source projects that contribute that code to internet-based warehouses. That code is then downloaded from those warehouses into your software development teams and built into the finished goods and software applications. So we looked at over 36,000 open source projects for this research. We looked at over 3.7 million releases across that software or across those components. And we also studied over 12,000 organizations developing applications using open source components. We surveyed over 6,000 developers this year for this study. And we also evaluated over 86,000 applications that were built using open source components to get a better idea of who the best open source projects were and who the best suppliers are of this code. So I'm going to hand off to Stephen Magill now, who's going to walk you through the first part of the research from the report, and then I'm going to come back and cover the second part.
Great, thank you.
Stephen?
Right, so yeah, I'm going to walk through the analysis that we did of the open source ecosystem and some of the results that we found there. And the first thing I want to talk about is this notion of faster is better. So we're at the DevOps Enterprise Summit, and as Derek mentioned, we have all these stories about how speed and release velocity, deployment velocity are really tied up with a lot of positive outcomes from a technology and business standpoint. And we've heard that in anecdotes during the experience reports that we've heard at the conference this year. And then we've also heard it empirically and rigorously validated by Nicole Forsgren's research and her work with her team. So this faster is better premise, it holds in the enterprise, but does it hold in open source? So can we find the same sort of signal, the same connection between velocity and positive outcomes in the open source world? And there's no reason to think that this would necessarily be the case, right? The enterprise and open source community, they're two very different worlds. On the enterprise, we can achieve multiple deploys per day, right? In the open source world, it's more about versioned releases, using semantic versioning to communicate API changes, and pushing out new code, on a several month time scale. On the enterprise, you have a consistent group of developers. There's some turnover and people switch teams and so forth. But by and large, you have a predictable set of developers. It's much more fluid on the open source side, with developers coming and going and many just contributing a single code change. On the enterprise side, our dev teams are well-resourced, or if that sounds ludicrous to you and you're snickering, at least predictably resourced, right? Maybe the budget's too low, but it'll probably be that same number or close next quarter. Right, on the open source side, those resources are highly variable. It's very difficult. It's much different doing project planning when you don't know how many developers you're going to have next week. So they're two different worlds. On the other hand, there are similar metrics on each side. So we can actually find analogous attributes on the open source side that correspond to some of the things that we're interested in and we track on the enterprise side. So deployment frequency, this key metric on the enterprise side, does correspond in some sense to release frequency. How often are open source projects releasing new versions? The time scales and the cadences are very different, but they're analogous concepts. Similarly, when we talk about organizational performance metrics on the enterprise side, things like market share and profitability, I would argue the open source analog for that is popularity, right? Open source contributors, they contribute because they want their work to have an impact, they want to improve other developers' lives, and so that means getting their code used, right? Which corresponds to popularity. On the enterprise side, this mean time to restore is a key metric of how well the organization responds to incidents and downtime and so forth. On the open source side, a very similar situation occurs when you have a security vulnerability that's reported and you have to push out a new version that mitigates that vulnerability. It's the same sort of all hands on deck, let's push a new release as quickly as possible scenario that happens when you respond to an incident in the enterprise. So to answer this is faster better question, we can look at these analogous attributes on the open source side and we can compare release frequency and popularity and see what sort of connection there is there. And so going into this research, this was our first hypothesis. We wanted to explore, do projects that release frequently have better outcomes? And we did find supporting evidence for this in the data. So projects that release frequently, if you look at the top 20% by release frequency, They're 5 times more popular on average. They have 79% more developers, and they're supported at greater rates by open source foundations. And these are all statistically significant differences in those attributes. And we don't know, so I'm stating here correlations, right? We haven't looked into the causation aspect of this to see whether these projects are more popular because they have more developers, or they attract more developers because they're more popular. We don't know which is the leading or lagging indicator, but that's one connection that we found. We also looked at these more security relevant metrics, so things like mean time to restore and time to remediate vulnerabilities. And I'm going to spend most of it actually talking about those security relevant and update and sort of responsiveness relevant metrics. But first I want to say a little bit more, following on to what Derek said about how we constructed our data set. So we started with Java components that were published to Maven Central. That was the starting set. And then we filtered out components that we didn't really have enough data about to analyze in a productive way. So for example, we're looking at things like update frequency. So a component has to have published an update, right? If it only ever released one version and that's it, that's the only version of that component, that's not helpful to us, right? So we filter those out. We also look just at components over the last 5 years because development trends, technologies, and tools have all changed over time, and we wanted to find interesting correlations in the data that hold for sort of the current development environment, right? We also filtered out components. There's a lot of components that just aren't part of the software supply chain, right? So like they don't use any open source libraries, and they're not themselves used by any other components. And so they're just sort of isolated, not part of this supply chain, not part of a dependency tree. And so we filter those out. So we do all of that, sort of selecting for what we need to collect the attributes that we wanted to analyze, and we get down to this core set of 36,000 components, and that really is what we focused on. And then for that 36,000, we had enough information to compute a variety of attributes, right? So we looked at popularity, measured as the average number of downloads from Maven Central for that component each day. Yeah. We looked at the size of the development team, the development speed, so how often was code committed to these repositories, release speed, presence of CI, and so forth. And then a couple of security and update related metrics, so security and update speed. And most of these we have for all 36,000. There's a couple that are based on GitHub metadata. So size of team and development speed, those are both based on information that we get from the GitHub statistics about a project. So those we only have for projects that were hosted in GitHub. There are about 10,000 of those. All right, so these last two metrics, security and update speed, they're a little bit more complicated, but they're really the core attributes that we studied here. So I want to spend a little bit of time talking about how those are defined. And so basically, they're both measures of how quickly an application responds, how responsive a group of developers are in various scenarios. One is more security-oriented, and one is more oriented just towards staying up to date. So to demonstrate these, I've got a graph here of a typical set of software releases, right? So we have 3 components here, A, B, and C. And you can view time as sort of marching along from left to right. And dependencies here are solid lines. So C depends on A and B, right? And in particular, version 2.2 of C depends on version 2.2 of A and 2.2 of B. And we have a couple of interesting events here, this vulnerability B event, right? So this is indicating that at some point in time, someone discovers a security vulnerability in component B. And so there's some period of time now where B is vulnerable, right? Someone knows about a vulnerability there, and it hasn't been patched. And then we're assuming that version 2.3 of B actually mitigates this security vulnerability. They patch it, they put out a new version that doesn't contain that problem. And so C, because C depends on B, also inherits this vulnerability, and it has a certain vulnerability time. But if we think about things from the perspective of C's development team, really the core time period to focus on is this one here, right? Because there's this time period where B has released a new version, that version patches a security vulnerability, and then this clock's sort of ticking for C to incorporate that themselves, right? That's the first point at which they can fix their upstream vulnerability. And so we're going to call this remediation time for C. And we can compute this remediation time for individual updates and average it for components and talk about this TTR metric, time to remediate. And then we have and so that's a security-oriented metric. We then have just a general update-oriented metric, which is the time to update. And so since B is a release, it takes some time for C to adopt that release. That release happens to be security relevant, but there's other releases that aren't security relevant, like A here publishes version 2.4. Again, the clock's sort of ticking to see how long does it take C to adopt this new version of A, right? And so when we consider that time period for all updates, whether security relevant or not, we call that time to update, TTU. And then we also look at what we call stale dependencies. So there's this idea that a component might release a new version, but not update all of their dependencies. And so those dependencies that are lagging behind, we call stale, and we account for those as well. So here, A is released version 2.3. It was out, it was published when C released version 2.2, but C didn't update to that newer version. All right, so those are the key metrics: time to remediate, time to update, stale dependencies. And then we're going to explore a number of questions about those metrics and how various open source projects behave with respect to update hygiene, security hygiene, et cetera. And I want to start with the security relevant one. So this is time to remediate, that security metric I was discussing before. And this is just a graph of the TTR behavior of the entire population. And so we can see, first of all, I want to focus on this median TTR. So down there, at the dot at the far left shows 180 days median remediation time, which means that 50% of the population takes more than 6 months to remediate a security vulnerability in a dependency, right? So that's already not great, right? And it gets even worse if you look at the far right. So the top 5% of projects take over 3.5 years to adopt security relevant changes. And those aren't projects that just never, it's not like a security patch came out and they just never adopted it. It came out, they did eventually adopt it, it just took them 3.5 years. So clearly, if you're selecting projects, if you're selecting dependencies to fold into your software supply chain, you want to be down here, right? You want to be identifying these projects that are attending to this, that are keeping on top of updates, not just to their direct dependencies, but to sort of everything in their supply chain. And so one question we had is, so this is the section of the population that's good from a security perspective, but are they just good about updating in general? Right? Are they just paying attention to security, or are they just keeping up to date, right? Which behavior dominates? And so what we find is that they're actually closely connected. So this is a graph of the time to adopt security relevant updates versus the time to adopt non-security relevant updates. And you can see there's a correlation here. So the correlation coefficient is actually 0.6 in this case. And so there is a sense in which the two track each other. And actually, if we, so that's one way to view it. We can also dig a little deeper or slice it different ways and find that if we look at MTTRs and MTTUs that are within 20% of each other, so trying to characterize similar behavior in terms of security and not security relevant updates, 55% of the population falls within that. And so that's sort of, if you imagine like a cone, a slice near that diagonal line, those are the projects that we're talking about there. And in particular, if you think about like the opposite of this, are there projects that don't update frequently but still manage to stay secure? We don't see a lot of that behavior, right? So if you look at the projects that manage to maintain better than average security behavior while having worse than average update behavior, only 15% of the population falls into that category. So this is interesting. So first of all, so that's hypothesis 2. Projects that update dependencies more frequently are generally more secure, and we found a variety of evidence for that. And that's an interesting finding because it gives you another way to evaluate the quality of projects, right? Like, okay, we're all interested in security. That's like the top line concern. And so we can evaluate that by looking at security update behavior, but a lot of projects never have a security vulnerability reported against them, right? So we have no data for those projects and no way to evaluate them. Whereas we have update behavior data across the board, right? Every project, we know how frequently they're updating. And so if we can say frequently updating is a good sort of proxy for quality and security and so forth, that gives us another thing to latch onto to include in our set of criteria for how we evaluate these projects. All So hypothesis 3 was that projects with fewer dependencies would stay more up to date. This seems intuitive, right? Like you have less to keep on top of, so you'll be better at like getting it done. We actually found the opposite. So components with more dependencies are actually better at keeping them up to date. And this was so not what we expected that we dug a little bit deeper and found that what's going on is actually projects with more dependencies tend to have larger development teams. And then projects with larger development teams tend to be better at keeping things up to date and just sort of attending to these project hygiene concerns. So you can see this relationship here. I've graphed the number of dependencies versus the average size of the development team. And you can see that that increases as dependencies increase. And so the more and more dependencies you bring on, the more pizza you have to buy. Yeah. All right, so hypothesis 4, and this is, I think, like the most interesting finding of the report. So like if you focus on one thing or take one thing away from this talk, think about this. So we went into this thinking probably more popular projects will be better about staying up to date. They'll be better about adopting security updates, et cetera, et cetera. Again, we found no evidence for this. In fact, if you look at, so first of all, there's plenty of popular projects that have poor update hygiene, but that's not really surprising. There's always outliers, right? But if you dig a little deeper, you find that popularity doesn't even correlate in any sense with update hygiene. And in fact, even if you just focus in on like the most popular projects, say the top 10% by popularity of the population, there's no statistical difference between the update behavior of those projects and the update behavior of the rest. So popularity is not a good proxy for update hygiene and security and so forth. And so, like I said, if there's one takeaway, don't base your decisions just on popularity, right? Look at other things, consider other factors. And so to see sort of some of the behavior that's behind that and get more of a sense of how different groups of project maintainers behave, we broke the data down further and looked at various clusters to see what behaviors were in common between different types of projects. And so we broke it down into 5 different categories, 2 that have exemplary update behavior, so these are in the top 20% of update hygiene, and then 3 that are not. And so one interesting thing is that among the exemplars, there's representation from both small and large teams, right? So there's a sizable set that has small development teams, an average of 1.6 developers per team, and are still staying very on top of updates. And then there's the large exemplars, which have, on average, almost 9 developers on their team. They have exemplary update behavior. They're very likely to be foundation supported, and they're high on popularity. And so this is sort of like the open source industrial complex or open source foundation complex, I guess. So it's that, Apache Foundation, et cetera, Linux Foundation, those sort of supported projects, those big projects that are really sort of setting a high standard for quality. Then we have the laggards, which are sort of behind an MTTU, high stale dependency count, just sort of not keeping up. One of the most interesting classes is this features first class. So I talked about these projects that are popular, but are sort of not keeping up from a security perspective. Some of those are in this category where they're doing frequent releases, and so they have the release bandwidth essentially to stay up to date from a security perspective, but they're sort of not spending their effort there, right? They're maybe prioritizing features or something else, whatever they're doing. They're not attending to security. They're just prioritizing features. And then there's the cautious group, which has good update hygiene. So they keep up to date generally, but they're not at the latest version. So you see them adopting updates basically a version or 2 behind. So they're not falling behind and staying completely out of date. They're generally staying secure, but they take a more cautious approach. All right, so this is that data represented graphically. I've got different colors. I've got the different groups tagged with different colors. And so you can see, first of all, that exemplar category is all the way here at the left. As I said, these release quickly and tend to be more popular. And so if you're sort of sourcing projects for your open source supply chain, you should try to draw them from here. This is a representation of what I was saying with popularity not being a good guide. You can see that in basically how far this box spreads to the right, right? We see on the x-axis here is average days between release, so how quickly do you release updates, how up to date are you staying? And then on the top is popularity, and so you can see there's some popular projects that are not great from an update hygiene perspective. All right, so now I'm going to turn it back over to Derek. So I've been talking about the open source supply side of the equation. Derek's going to say more about the consumer side and what's happening in the enterprise when we look at how they deal with open source dependencies.
Cool.
Thank you.
Thanks, Stephen. So the thing that we found as we were going through the research, one of the things that we were looking at was we saw all these open source projects that were updating frequently, and we saw this exemplary behavior, but we wondered, okay, well, what are developers doing in your enterprises? How are you behaving with dependencies? So while we were doing this, in the middle of doing this research, we said, let's go out and survey a bunch of developers, which we did. We surveyed over 658, I think 658 is the number. And we asked them about how are you managing dependencies? Do you have a process for managing your dependencies? Do you have any automation that you're using to manage dependencies? Do you have a process in place for removing troublesome dependencies when problems arise in there? Are you using the latest version of dependencies in projects that are out there in your environment? So the surprising thing about the survey was how many organizations and developers said that they had these practices in place. I think we all kind of expected about 9 or 10% of these organizations to say, yes, we're doing this. I think we all kind of felt like these answers might be more aspirational versus what they're actually doing, or they're just representing we have a part of a process in place to do this. It might not be the most mature process, but there is some part of a process that exists or some piece of automation that exists to support us. It may not be comprehensive in that realm. But when we looked at these practices and we began to identify the clusters of exemplary behavior versus non-exemplars, what we found out is that in the exemplar behaviors, they were 10 times more likely to schedule updates of dependencies. They were 11 times more likely to have a process in place to update dependencies. They were 12 times more likely to have automation in place to support these practices. But the cool thing about this, and the finding at the top of the mountain here, is that when it came to updating dependencies, whether there was a security vulnerability in place or it was just the practice of updating dependencies, that it was a lot easier for these organizations. They were less likely to consider that activity painful if they were doing this frequently. So when you're climbing the mountain every day, when you're updating your dependencies every day and you have these practices, it's pretty easy, or it feels easier to do this. If you climb the mountain once a year, you're trying to update your dependencies once a year or once every other year, it's going to be a difficult trudge up the mountain. And that's just like, hey, you know, can we do one deploy a day per year, right? Or multiple. Messing up my analogy, but if you're trying to do multiple deploys a day, right, deployments get a lot easier, right? When you're doing one deploy every 6 months or one deploy every year, it's a lot harder, right? And so we're seeing the same behavior within the enterprises and how they're managing their open source components and dependencies. The other thing that we also found through the research, and this was part of the survey, we went out and surveyed over 5,500 developers. In this one, we asked the organizations to identify, are you using DevOps practices? Do you consider yourself to be mature in your DevOps practices versus having no DevOps practice? And of those organizations, we asked them, do you have an open source policy in place? And if you do you follow this process? Where automation exists more in these environments, that was also part of the survey, we found where automation existed, it was more difficult to ignore. So developers are aided by information about the components, what's a good component, what's a bad component, and they're 2.5 times more likely to apply those governance policies in those organizations where automation was more present. The other thing that we wanted to understand is what open source components are everyone using out there? And what's the quality of those components? And one quality that we looked at across these 68,000 applications was what is the age of the components? You can see within this chart that 51% of the components are 3 years old or younger. So they've been developed or released in the last 3 years. But half of the code within the applications that you are all building is 3 years old or 3 years or more old. 3 years old or more. So one, that means you're relying on parts from suppliers that have been out for a long time. And this makes a difference because when we look at the vulnerability defect ratio within these components, you see that the components that are younger than 3 years old have a 9.3% defect density, and those that are older than 3 years have a 15% defect density. So if you just had a rule in place that says your developers can use any open source components they want, as long as they're 3 years old or younger, then you can reduce your security defect density by 65% just on that practice alone. You don't have to say use more secure components. You just have to say use the latest, newest versions of these components, and you will by default or by consequence remain more secure as part of that. We also saw in this survey that exemplar DevOps teams were relying more on tooling to tell them about security information and security issues within their applications versus the laggards or those that didn't have DevOps practices not relying on tools as much. So when tools are present, one, they're alerting developers to more information. We saw in one of the previous slides, they're more likely to follow that information that's provided by their tools and by the automation, and therefore staying more secure as a result. And at the end, the part of the research that we showed as well is in managed software supply chains, where you're looking at the quality of these components and the attributes that are being consumed among the enterprise, they're staying 55% more secure or have a lower security defect density than those in unmanaged supply chains, where 20% of the components in the applications developed in unmanaged software supply chains had known vulnerabilities when the applications were built. So we went from about 8% of the downloads being known vulnerable to 20% of the components that were used in the end applications being vulnerable. So as we wrap up, we wanted to offer some quick takeaways from like, okay, you got this data, what do you do? There's more data even in the report. But the first takeaway that I'll offer is you have to start with observability. You have to know what you're using. If you don't know what open source you're using and what you're consuming, you cannot do anything to change using, picking the right quality from the right suppliers. You have to have an active view on what you're consuming within the enterprise and where it is within your applications. So
yeah, and then pay attention to the criteria that you're using to select these components. Don't just use popularity, as we were saying.
Yeah.
A better proxy is maybe release frequency, things like that. And then I'd ask everyone to be good open source stewards. If you're making contributions to open source, think about updating dependencies. I was surprised in the research by how many popular components just have very out-of-date dependencies and sort of transitively are importing security risk. And so, paying attention to fixing that up. And then as you contribute to open source, if you put a project out there, this bottom aim for 4 releases, with 80% of your dependencies up to date, that will put you in that exemplar category and ensure that you're one of these better performing open source projects and not introducing vulnerability into the supply chain.
Yeah. So the quick and easy answer, if you want a copy of the slides or the State of the Software Supply Chain report or the 2019 DevSecOps Community Survey, my out-of-office message is on. So if you email weeks@sonatype.com today, it's only on today. It has links to the report, so you don't have to register to download it or anything like that. I tested it, so it does work. and you can find those and download those and read the research yourself. We didn't cover all of the complete body of the research in this presentation today, but thank you very much for attending. We really appreciate it. I know the other sessions coming in, but we'll be available for questions. The other thing I'll say, just because this is recording, my out-of-office message is not on all the time. So if you were watching the video at some later date, please say, hey, I was watching your presentation at DOES in Las Vegas. Could you send me those slides so I know what you're referring to? There's always someone that just sends me an email with blank with no reference, and I'm like, what is this about? So just a note for those watching the video. So thank you.
Thank you.